Thank you for joining. Today I presented the upstreaming status for the ICEG demo integration based on CES2023 demo. First slide shows my personal information. So my name is Naoto Yamaguchi from AISIN Corporation. More detail is please check my slide information. So this slide shows today's presentation outline. So first point, I presented the background for our ICEG activity. Second section, I presented the CES2023 demo upstreaming. Finally, I conclude this presentation. At first, so Azure Instrument Cluster Expert Group launched at 2019. So AISIN motivation is create a best platform for instrument cluster, not a platform based on the conventional RBI. So these are different system requirements between RBI and the cluster. So cluster side requires functional safety and quickly boot time and etc. So this platform is built from all of open source technology. So need to independent from existing proprietary software component. It's a first point. Second point is need to be able to choose open source software component or proprietary software component. This slide shows a generic system design. So this slide is a generic system design as shown. So instrument cluster and RBI into one systems. So instrument cluster is required to the functional safety. It's the second point. And this system characteristic is connecting the one or more displays and connecting to the speakers and connecting to phone by Bluetooth, USB, and Wi-Fi. And connecting to the USB devices, such as the USB mass storage glass. Connecting to on-board, off-board sensor devices by using the I2C, UART, and the SPI, and the SOTRA peripheral interface. And connecting to other in-vehicle ECU by CAN, Ethernet, or etc. These are our generic system design. So what are product development issue? First point is quality and robustness. So instrument cluster required the functional safety, typically SLB. Because instrument cluster has telltale functions, this one and this one. So it shows a critical failure information to driver. Next point is quality management. So there have a separate quality requirement between instrument cluster and RBI. So first point is the approach for the functional safety. So main function is the very function of our system design. Requires advanced quality management and open innovation and cyber security and fast boot and others. Second part is the functional safety point. This part is what function does it include. So it's depends on your system design. Which OS do you use and which communication method do you use? It's depends on your systems. So our approach is typical design is a safety island approach. main function and the safety function isolated the isolation method. So this isolation method use hardware separation using a hypervisor and another solution. It's depend on your systems. So ICEG focus to the main function side. So main function sides have many puzzles. So IVI part requires rapid automation. So new features are added, short-term development and rapid bug fix. It's the IVI side typical requirements. Instrument cluster side requires advanced quality management. For example, full path coverage testing requires and formal verification and carefully bug fixes. These are fast puzzles between IVI and the instrument cluster. So IVI side requires various functions. IVI has many pre-installed applications and application installed from App Store. On the other hand, typical instrument cluster design is a selected function is only. But this function is a completely combinational verification is required, and the first boot up is required. It's a second puzzle. So how to fix this issue? So our approach we call a QMI solution. So our answer to the puzzle issue in one more isolation method, which take one more layer to isolate to the function by using Linux container technology. This part. So each software is developed on quality management level. Cluster part developed by the cluster quality management. IVI side, as the IVI level quality management is using. So when all software integrated mix into one big software, that means the IVI and the cluster into one root file system. These two quality requirements will cross-propagate around one big software packages. So our approach is isolate each software using Linux container technology. We call this method QM isolation. So technical point for QM isolation. So if I use the Linux container, this Linux container is an operating system level virtualization method. Linux container realized to the running multiple isolated Linux system on a host using a single Linux kernels. So isolated root file system on Linux kernel by using change root. Control resource by using cgroup. And hide resources from the other container by using the namespaces. So this function is realized to key feature for QM isolation. It's a technical point. So more detail of this technical point, please check our two presentations. One was the previous AGL all member meeting presentation. Another one is last embedded open source conference EOSS presentation. Please check it. So next topic is CES2023 demo upstreaming. So first big point is that I need to develop a demo. That answer I show this slide. So UCB has many seed software. AGL user pick up any software from AGL UCB to use on development. Because AGL UCB is an incubator. What should we do? So ICEG developed by many technical seed software for QM isolation. Need to show how to incubate own software from UCB seed software. For example, we get a UCB. We want to create a goal. If no demos, one developer creating the scramble egg. Another developer creating the snake from a UCB egg. But if ICEG provides a demo, we can show the success story. That's our motivation of the demo development. So CES2023 demo integration goal. So to show the strong point for Linux container-based systems. So easy to integrate with some system on one Linux kernel. Easy to share the device between systems. Easy to isolate between systems. Defined demo item is IC and IBI system are running on one Linux kernel with one SoC. Realize IBI system exchange to show software upgrade use case. IC has one display and IBI has one display to show that device sharing, display sharing. Finally, IBI crash demo to show between container isolation. This work by the three developers. First developer is me. I work to the container demo integration and develop embedded use case support in Linux container and a MOMI software stack for demonstration and upstreaming work. Second developer is Hiroyuki Ishii from Panasonic Corporation. So he worked to the container demo optimization and developed the container exchanger and upstreaming and demo integration, IBI side. Third developer is Harunobu Kurokawa from Lunas Corporation. He worked to the extra BSP development and graphics and display sharing work and IBI demo integration. Please check this picture. He's a fisherman. His extra work is developed seafood dinner. So starting point for IC container integration. So AGL upstream activity for IC container integration is AGL reference hardware is supported. Auto start to guest container. This one. Each guest container has one own display that managed by DRM is managed. This one is a cluster. This one is IBI managed by DRM is managed. So cluster container supporting reference instrument cluster GUI. Simple IBI container is supporting home UI with two sample application. What defined demo items is available. IC and IBI system are running on the Linux kernel with one SoC. It's already available in current implementation. And IC has one display and IBI has one display to show display sharing. It's available in existing implementation. We need two extra development. So need to develop two development items. One was the realize IBI system exchange. Another one is the IBI crash demo. So more detail for the defined development items. So enabling for IBI guest container, Qt based IBI and HTML5 based IBI, and a flutter-based IBI. And the existing IBI is renaming the MOMI IBI. And enabling container lifecycle management because it needs to the container exchange, start and stop and change. And the clocks and reboot support, it depends on this management method. And one more requirement is the catch up latest AGL common features, enabling SE Linux support in host side. So this slide and the next slide shows a detail of the, our work, our development work. This side change is remove TTY device dependency from AGL session and AGL compositor, and removing FS tab mounting, and disabling the RNGD device, RNGD services. So add DRM QMS support to psplash and fix few bugs that not depend container integration. It's upstream bugs. Host side changes enabling SE Linux feature and change some device file permission and create container config for more 3 IBI demonstration. This slide means only this change to realize migrate from existing IBI, Azure IBI to guest IBI software stack. Next shows enabling container lifecycle management. So this feature developed in parallel. So first one is a lightweight implementation. Second is the full feature implementation. So the lightweight version was used in CES2023 demos. So this slide shows the result of the demo development for CES2023. So it's available to the all of software run on the one AGL reference hardware. For demo IBI exchange by mini keyboard, this keyboard. So this topic available to the IBI system exchange to show the software upgrade use case. So when IBI container is crashed or exchanged, IC side GUI not affected. So it shows available to IC has one display and IBI has one display device sharing use case. And the IBI crash demo show between container isolation. It's available to this demo topic. So more deeply implementation shown this slide and the next slide. So this system launched by Systemd. Systemd launched to the DRMS manager and the mock container manager. So the mock container manager mount all container image partitions. And the mock container manager launch cluster container and the default IBI container using LXC runtime. So the mock container manager receive a container exchange request to Qt IBI. This command from the mini keyboard. The mock container manager stop MOMI IBI using LXC runtime. And the mock container manager runs Qt IBI using LXC. It's a demo implementation detail. So next topic is upstreaming detail. So for upstreaming development, so which is difference between demo development and upstreaming? So in case of demo development, not required to the reproducible, not required to the documentation. No problem for many workaround and hand operation. Not need CI strategy. On the other hand, in case of upstream, required to reproducible, required to documentation, and avoid many workaround and many hand operations, and need to CI strategy. So issue for upstreaming. So first issue is how to keep AGL IC-based minimized common software stack. Second issue is how to integrate demo-specific feature in host. And third issue is how to build AGL demo-based guest container. So first one is a detail of the first issue. So CES2023 demo is image, including the unnecessary packages. It's many packages. What is the issue? So in downstreaming demo, that is no issue. Because not reuse this software in downstream development. But in upstreaming, that is big issue. So AGL IC software stack developed to use downstream product development. That means must be keep easy to drop demo-specific packages. This table shows the issue. So previous demo integration having the about 900 packages. On the other hand, after CES2023 demo integration, so about 1,200 packages. The including kernel modules, it is not issue. Because it will reconfigure for the product board. But the most issue is this Python package is adding. So this package imported by the SE Linux, but not used in final image, because it only to use the development. But it's too difficult drop these package from images. So we are modified to SE Linux recipe to remove Python dependency. It's our first issue fix detail. Second issue is CES2023 demo has some demo specific package. Most point is this mini keyboard support. This keyboard controlled by shell script based container management, mock container management. So that means container exchange method need to some demo specific packages. What is issue is this point. So this demo feature is required by AGL user because if this package supporting, so easy to understanding the container exchange detail. On the other hand, this demo feature must be departure from in downstream product development. How to fix this issue? So created a config option specifies this demo. As a result, easy to departure demo specific package. It's a second fix point. Third point is how to build. So CES2023 demo image required too long build time. The best demo build takes 2 hours, this one. That is including the container host and the cluster and the MOMI IVI. So, what is the issue? It's too long. The full demo build takes additional 4 hours. That is including the Qt, Flutter, and the HTML5 IVI. Total requires 6 hours. It's too long. So in ICEG development case, Azure IVI demo-based case is only to use the integration test for container host features. Want to avoid Azure IVI demo build times. Not need 6 hours. I want to reduce to the 2 hours. When Azure user want to use the Azure IC container integration, they have to wait the long build time, 6 hours. How to fix it? So we created a pre-build binary-based integration method. So if this method used, so we can reduce the Qt, Flutter, and the HTML5 IVI build time to use a downloaded binary. That means only needs 2 hours to create this demo integration. So this slide shows the improvement for upstreaming code from CES2023 demos. So web-based container control interface is added. So CES demo integration is fully dependent to special mini keyboard. That keyboard does have compatibility for similar keyboard. So this keyboard vendor ID is A, another keyboard is a B, but these two keyboards similar keyboard. Second point is added another web-based container exchange feature that aim to easy to play container exchange. So second point is a full feature support to container lifecycle management. So ICEG research and development container management features. So that need to support container launch, shutdown, monitoring, and rebooting method, and extra support some devices such as SysFS, GPS, GPIO, and IIO, and more devices. And need to support dynamic behavior for devices, for example, USB devices. So, and control resource support such as CPU, memory, and more is needed. Third point is the full feature support at the Raspberry Pi 4 board. It is the best gateway for newcomers. We can't provide a pre-built binary for Alpha Gen 3 devices. That limitation is dependent on the GPU driver license. Raspberry Pi 4 is possible to provide pre-built binary for user under AGL IC-EG because not having a limitation on the license. So improved architecture and the behavior as shown. So systemd launching the DRS manager and the container manager. It's the same behavior for CES2023 demos. So container manager mount a cluster container image, only cluster container. And the cluster container device, set up device and launch a cluster container using libxc by the container manager. Next is that the container manager mount default IVI container image. And set up device and launch a default IVI container using libxc. That means, so Full feature container management daemon supporting the reduced resource. So the container demo service received container exchange request to Qt IVI, received from keyboard or web UI. So the container demo service sends active container change and IVI container restart command to container manager. This point is separation point of demo feature and real for product development features. So the container manager stop Momi IVI using libxc and unmounting these images. And the container manager mount Qt IVI container images and set up device and launch Qt IVI container using libxc. It's a new after improvement demonstration. So these are shown the upstream activity. These are AGL Gerrit logs. All of 43 patches. All patches was merged in current status. And this activity demonstrating outside of this room. Please check the demonstrations, and if you have a question, please ask to me or another presenter. So finally, conclusion. So about this presentation, talked about the AGL IC-EG background and the target systems, and shares our QM isolation concept. So our past presentation focused on the technical part. So for example, my previous AMM presentation and the EOSS presentation and more old presentation. In this presentation, aim to show which system can be realized based on AGL IC container integrations. So shared CES2023 demo activity and the latest development activity. Our future work continue to work how to realize other use case support to improve the embedded Linux container usage, use case. That's all from my presentation, but one more information. So AGL Japan member now work to the information provider. So we use Twitter. So please check this Twitter account. This information provided by Japanese. So easy to understanding Japan members. It's one more additional information. Thank you.